everyone. I wanted to tell you I caught up on some things, and if you look on the website, the MyWLC website, and if you go to class multimedia, I just want to show you that I've caught up now with chapter 1. I've got, we actually had 4 days, but the 4th day was the movie. And I'm working it out so those movies will be available to you too. But anyway, do you notice how it says, actually we have 4 things up there. We got that day when I did major lessons. That was the first day. And then I'm just calling it chapter 1, day 1, chapter 1, day 2, chapter 1, day 3. I caught up. I had a marathon video processing session all evening last night. It takes quite a while, but anyway, I'm going to try to keep up on that. My goal is that the night, like sometime by later tonight, I'll have this one up. I don't think I can beat that. And maybe the very quickest, I might have it done like before I leave at 4:30 p.m. But my goal is for sure by that evening, if you want to go back, because otherwise some of this stuff's getting a little historical now. But still, that's valuable too. Can't remember? I don't know if you want to listen to all that stuff again, but you could actually, if you wanted to, get ready for the test. Okay. So, we are beginning chapter 2. Chapter 2 is, as you already know, called Describing Distributions with Numbers. Felix, welcome. I wanted to mention, you should know that on the MyWLC site, there is a tab. Let me just go back to where the standard is. Here's what the when you come to the site, there's a tab over on the left called Class Multimedia. And if you click on that, there's a section for audio. And if you go down a little further, there's a section for video. These 4 things on chapter 1 are literally recordings of the classes. So especially for you, not having been here for those might be valuable for you. Okay, chapter 2. And we'll go at it objective. I'm going to go at it these 3 objectives first. There are actually, I think, 7 in this chapter, but these 3 kind of go together. And we'll do them, of course, one at a time. And as a little intro, you see that one of the things on here is finding a mean. I just wanted you to know that there are lots of kinds of means. We are going to use only one of them, but I just wanted to show you some of them. There's a harmonic mean, a geometric mean, an arithmetic geometric mean, an arithmetic mean, and a root mean square. And then there's that mean guy that lives down the hall. No, I'm just kidding. The one we're using is the arithmetic mean, which is good old average. Add them up and divide by how many. You guys all know how to do that. You've been doing that since way back in elementary school. That's the one we're interested in right now. Actually, so geometric mean is pretty commonly used too, and actually all of these are important, but arithmetic mean. Okay, so you don't have to know these. I just thought I'd show you that if somebody says to you, well, I'm finding the mean too, you might want to check which one, because there are a number of them. Okay, so here we go. We call these 3 guys mean, median, and mode. We call them sometimes the measures of central tendency. So in other words, these are ways that, you know, in chapter 1, we learned about these distributions. And we learned that sometimes what? They're not symmetric. Sometimes they're skewed. Sometimes we're almost always interested in finding the center and the spread. Well, first of all, how could I measure the center? Answer? 3 waves. You know, it's kind of like, how many ways do I love thee? Let me count the ways. Here it is. How many ways can I find my center? 3 ways. Sorry. Anyway, they are, first of all, the mean, the arithmetic mean. And there's, you know, this just says add them all up and divide by how many there are. You get the notation here. The x1 means x, the first x, the second x, the third x, all the way up to the nth x. And if there are n of them, divide by n. Now I'm going to also introduce to you this other notation. This is capital Greek letter S. It's called sigma in the Greek language. And it's just like in the, you know, in the English language, S is the first letter of sum. And that's exactly how the Greeks use it. So all this means is add them up. And it's just saying add up all the x's. Add up all the x's and divide by n. So this is just another way of saying this. Now I'm introducing it to you. I'm not going to cram, well, you're going to find I'm pretty light on formulas in this class. I am not. Honestly, one of the negatives of one of the stats classes that I took in grad school, it was just inundated with formulas, and we didn't do much with real data, and it was like the formulas were just piles of things, and I didn't really get into their use, and I didn't enjoy that course that much. So anyway, we're not going to be heavy on formulas, but at the same time, I want you to recognize them and not go, ugh, what's that, you know. I want you to at least, so all that big, funny looking thing is a capital S for sum. Okay. The second one is the median. It's the one they usually refer to, like for example, there's a median on Blue Mound Road. Sometimes we call it that, don't we, on a boulevard. It's not a bad picture of what it is. It's the central piece of data. Let me explain. If you line them up in order, it's literally the one in the center. And that's not the same as finding the average. And then the third one, which is the least of the least used of these three, and yet it's important, it says which data happened the most. It's kind of like the democratic one. If we had some kind of a voting class on like which method do you like the best, and if we gave the award to the one that had the most votes, a plurality vote, that's the mode. Okay, so there's just a quick intro, and then I thought what we would do is we'll take some real data and we'll just crank through it and make sure everybody knows. So here we go. I've got some data from page 32 in the textbook. Not that you had, you know, and see those numbers on the beginning page of your chapter? Yeah, well, I've got them listed on the right side of the page there. And I think I've got them in the same order they are in the book. So the idea is, let's find the mean. Okay, well, let's go ahead and do it. Let's do a little addition here. Let's see what we got. 5, 10, 15, 19, 21, 23, 27. 3, 5, 10, 15, 20, 23, 26, 29, 32, 37, 40, 43, 56. So I get a total of 667. And we're dividing by 15 of them. So 44 and 7/15 is the mean. And of course you could put that in decimal form too. I think I did that correctly. So there's no question about that, right? Okay. Now, the median is a different is a different problem because the median, I've got to have, here's one of the downers of the median. In order to do a median, you have to have the data sorted from least to greatest. And that, I mean, it's no big deal with 15 numbers. But when you have thousands of numbers, it is a royal pain in several parts of the anatomy. Okay? Of course, that's where technology is wonderful. Technology will take care of that very quickly. Right now, just because we only have 15, let's line them up here. What do we got? 4 is the lowest number, I believe. What's the next lowest? 25, thank you. I better sketch them off here. So we got 4, we got 25. 330s, thank you very much. See, I have automation right now. I gotta just cross off the 30s here. There are 2 32s. Let me cross off the 32s. And we have a 35. 350s. I'll have to go on to the second row here. Cross off the 50s. Let's see, we have a 55. Is that next? Mm-hmm. And then we have a 60, 74, and a 110. Is that it? Mm-hmm. And we should have a total of 15. Okay. Now, if you have now a little strategy here. If you have 15 numbers, is there a middle one? Yeah. Well, how does the rule work? If there's an odd number, then you'll have a middle one. If there's an even number, you don't. Now, we happen to have an odd number, so what would be the middle number? Wouldn't it be the 8th one? So 1, 2, 3, 4, 5, 6, 7. So there's our median. Notice the median and the mean are not identical. They won't usually be identical. Occasionally they will. What are you going to do if there's an even number? Take the 2 middle ones and literally average them. Correct. So you might want to write yourself a little note. So if I ask you to find a median when there's an even number of data elements, then there must be 2 central ones. Take those 2 and average them. Okay, finally, let's do the mode. Well, which one has the most votes, so to speak? Well, we got 30 with 3 and 50 with 3. I think those are the 2 winners, aren't they? Okay, when you have multiples like that, we would just say 30 and 50. You can have multiple modes. Now, the only time we don't do that is, what if everybody had a vote of 1? Then we just say, this is stupid. You don't write them all down as tied. You just say, there is none. So, if you can have many modes, like we could have had another one that also had 3. You write them all, you list them all. Unless, if they all tie for the same thing, then we say there is no mode. Make sense? Like this is by far the most used one, but you're going to find this one this one's really got some cool advantages to it. Even though it's a pain to get things sorted, the results are important. I would say this is used sometimes, but these are kind of our 2 mainstays up on the top here. Okay? So there are 3 ways to measure central tendency that we're going to be using, and they are mean, median, and mode. I just thought I'd show you a pictorial view of some modes, just to get a little more used to the mode. This is a histogram. Would you agree that the mode is 3? And if so, why is it? Could somebody just explain? Why does this illustrate a mode of 3? Well, let me ask you a question. Is it because of this 3 or is it because of this 3? So here's what this is saying. 1 got 1 vote. 2 got none. 3 got 3 votes. 5 got 2 votes, etc. You know. So why is this the mode? Because it just has the most votes, right? So, okay. How about this next one? Does it make sense that I wrote down mode 2, 6? Yeah, we got a tie between those two. And, okay, so we got a little practice in. Now, I guess we haven't really done number 3 yet. I'm going to get to that. Are we going to do that now? Just a minute, I got to find my way here. Yeah, how did I do that? I dropped that. Excuse me a second. I see we, that's supposed to be a median, not a media. Okay. Anyway, I guess I'm going to hold off on the comparing of the mean and the median. We're going to be doing that later. Hopefully we'll get to that today. Okay, the next thing we want to look at is a group of 2, something called finding quartiles and determining the 5-number summary. I guess there's really 3 things because we're also going to learn how to do box plots. But once you know a 5-number summary, a box plot is it's almost identical. So, a little bit earlier, what were we doing? We were finding center. Now, we're going to find several ways of measuring spread. How spread out is the data? And remember, I think it was in the movie, they were pointing out some two types of hospital treatment, and they had this real spread out one with heart disease. Could be anywhere from 1 day in the hospital to, I don't know, like 29. And then they had a second one, and it only had a very small range. So even though, they both had about the same center, they had a totally different spread. Yeah, it becomes important to measure spread. So what I did is I've got some data up on the slide here. And this data, for convenience purposes, is already sorted from smallest to biggest. In fact, are those the same numbers again? I think they are. Yeah, the same ones we did a few minutes ago. The first one is range. Range is really, really simple. It's the high minus the low. So in our situation here, it's 110 minus 4. The range is 106. Okay, so that's not a huge deal. Now, quartiles. I guess you could say this is kind of dying and going to median heaven, because what we're going to be doing is median over and over and over again. Okay, so step 1, find the median. Now, we have already done this. Remember how we found this was the central number just a few minutes ago? So, in effect, let's just write that down here. That's our median. And by the way, that's also called, I don't know if I should have used those, it's really called quartile 2, it's the median. Okay, now, in effect, what I have done is I have divided our data into 2 chunks. Chunk 1, chunk 2. Now what I want to do is find, of this chunk, what's the median? And then, of this chunk, what's the median? And so, take the first group up there. How many do we have, first of all? We have 7, so there's a middle number. And what is it? 30? So there's Q1. And what's the middle number in this group? 55. That's quartile 3. And then, really simple, just put down the low and the high. We sometimes call the low Q0 and the high Q4. So I'll just go through what we did again. We found the median. That's our second quartile. Then we found the median of each of the two halves. Those became Q1 and Q3. And then we simply put down the low and the high. That's Q0 and Q5. That's our 5-number summary. It tells you where the center is and where the so this is like the 25% mark, the 50% mark, the 75% mark, and then you got 0 and 100. If you want to think of it as like it's almost like on your computer as you're doing a download. When it gets a fourth of the way over, that's Q1. When it gets halfway done downloading, that's Q2, and then Q3 is 75%. Q4, we got the whole file. So, what are the quartiles? Even though I don't have anything written here, basically those are these three in the center here. Q1, Q2, Q3. Sometimes we also refer to Q0 and Q5, but those are... Okay, so that's just doing, except for the range, which is subtraction, the quartiles is just doing median work. There is a way to do this in Excel. You have to go in and actually type a command in. Maybe I should just open Excel and show you that. Except I don't know if we have that data in there. Let me see what I can come up with. I don't expect you to know this one in Excel, but I just want you to be aware that you can also type in formulas, and I'll just give you a quick look at that. And I don't think that data file is probably, because it's not very big and it's not a problem, it's probably not listed. But I'll just I'll make some numbers up. Okay. Okay, so there's just some data I made up. Now what you could do is to put in a formula. So let's say I want to, I'll leave a little space here. Let's say I want to put the 5-number summary down here somewhere, okay? So here's what you can do. You want to type in a formula, either hit the plus sign or an equal sign. Either one, Excel figures out what you're doing. So right away it knows I'm putting in a formula. You probably also notice not only is there an equal sign there, but up on this line the formula appears too. What's nice about having it up here is if it's a long formula, you got a lot of space. Secondly, you can come back here and edit the formula real easily. Whereas here, well, it depends on how wide your cell is. Sometimes you're cramped. So now you can type in the word quartile, which is the command for this. And notice right away it recognized. I typed in QUA and it's saying, yeah, I bet you want quartile. And I think if I hit enter, I can't remember. No. Let's try that again. I'm trying to remember how to take advantage of that. Anybody remember? What key, does anybody know? Okay. Right, but what I mean is, I wanted to take advantage of that found quartile. Does anybody know the keystroke you use for that? In some things you hit enter, but, well, anyway, not important. Okay, now, put a parenthesis, and you notice it even prompts you. Down here it's saying, okay, you need an array, comma, and then you need your quart, means which quartile. So for the array, I want to do A1 to A11. So what I do is I type down A1 colon A11. There's my array, and you notice it found it and it even highlighted it. And it said, yeah, okay, I got it, comma, and now tell it which quartile you want. Now I'm going to put 0 here. This is, I know you're thinking, what? That's going to give me the low, and then below it I'm going to do quartile 1, quartile 2. Okay, so let's close parentheses, hit enter, and it says, up, there's your low, 23. Okay, let's do the next. And now let's do quartile 1. And then quartile, we're up to 2. Quartile 3. And quartile 4. So there is a way, so there's the 5 numbers summary using automation. And the cool thing is I didn't have to sort the data. You know, actually, that's another thing I could have done. You know how easy it is to sort in Excel, although I'm not totally into Excel 2007 yet. What you can do is highlight your data. Well, I'll tell you what, let me just copy it and we'll paste it over here. And then highlight your data and here's the sort filter on 2007. And you just want what? I want from smallest to largest. And bingo. So you can also do that real nicely. So it's got a lot of nice advantages. Especially, I mean, if you have 10,000 numbers, you do not want to sort those manually. And that's, I can't imagine not using a great tool like this to do that. But anyway, so again, I would like you to be able to do it both ways. All right, let's get back to, so that's what I was indicating here. Here's just a sample of how to do a quartile. Again, it's either an equal or a plus. You don't need both. It's okay. The word quartile, parentheses, the range of data that you want to operate on, comma, and then this represents which quartile you want. So this one would return the second quartile. So why is that slide there? To show you how to do it in Excel. Okay, next, let's do a box plot. All this is the picture, so to speak, of the 5-number summary. Which I already forgot. Somebody have it written down? What's Q2? Or what's Q0? That was 4? 4. And Q1? Thank you. Q2 is 35. Right? Yeah. Q3? 55. And was it 110? Thank you. Okay, so just bringing back those numbers, here's what you do with a box plot. I made actually you don't really need a bar on the bottom. What you really need is just one scale. Does it have to be vertical like this? No, it could be horizontal. But again, I like vertical. I don't know, vertical seems to work better. So what I'm going to do is make a box, and I want the box, I should change my color here. I want the box to be from 30 to 55. So, and then I'll explain all of this in just a second. And then we're going to put a line there. Then we're going to do another line up to 110. See, those are, so that's going to go up to the bottom of the L there, and then I'm going to do another line down to 4. And then just to finish it off, we put a little tail on there like this. And that's a box plot. Now, you probably noticed this is down here, that's the Q0. Q1 is right here. Q2, Q3, and way up here is Q4. So the box goes from Q1 to Q3. That's where it gets its name of a box plot. Q1 to Q3. The central half of the data. Would you agree that each of these is a quarter, right? 1/4, 2/4, 3/4, 4/4. And so each of these is a fourth, and if I take these two central fourths, I've really got the central half of the data. And the box represents the central half of the data from Q1 to Q3. Then we throw the median in at Q2. Notice it doesn't have to be in the center of the box. Like in this case, it's not. It's down toward one end. And then we draw what we call whiskers, and the whiskers go to the Q0 and Q4. So it's sometimes called a box and whisker plot, or sometimes just called a box plot. Does that seem to make sense? Pretty simple again. I'm sure you guys, I need you to be able to read box plots and make some. Okay. All right. Now I need to talk to you about the 1.5 IQR rule. Well, first of all, you got to know what IQR is. IQR is called the interquartile range. And you know, maybe we should just go back here and let's label that on this slide. So from here to here, you know, from Q1 to Q3, that distance is called the interquartile range, or abbreviated IQR. Yes?
Does it not matter how far left or right you go with your box plot?
Yeah, how fat do I make it left and right doesn't really matter at all. Correct. No, in fact, I could have drawn it horizontally if I'd have put my scale horizontally. Did you get his question? It was a good one. You know, how fat can I make my box? It's totally up to me. Has not really. I shouldn't have put that bar on the bottom because that dimension. Why don't I take that off? Because this thing might be throwing you off. This actually down here has nothing to do with the plot, and so it's really a one-dimensional plot. Could I have taken that whole thing and turned it sideways? Yeah. How wide should the bar be? It's up to you. So do you guys see what the interquartile range is then? It's actually what? What's the formula? It's just Q3 minus Q1. And so, notice now back to this slide. Interquartile range, Q3 minus Q1. Okay, now here's the principle. The official way, you know, up until now, what have we called an outlier? Just something that, in the words of, you probably don't even remember, a guy named John Denver, but in the words of John Denver, an outlier is far out. Okay, that's all it is. It's something like way on either end is an outlier. He used to say that all the time. Anyway, the official way to determine if it's an outlier is by finding the IQR, doing this subtraction, and multiplying it by 1.5. Now that number, if you add it on to Q3, and you've got something past that, that's an outlier. And if you subtract it from Q1 and you've got something above that, that's an outlier. Let's go back and I'll make sure you get that down first, and then I want to back up and let's actually go back to our box plot, and we'll see if either 4 or 110 are outliers. Okay? Is everybody? So one more time, a point is a suspected outlier if it lies more than 1.5 IQR below quartile 1 or above quartile 3. Okay, let's go find out. Well, what's IQR in this problem? What's Q3 minus Q1? 25. And then what's 1.5 times that? $37.5. Okay? Now, what's Q1 minus 37.5? It's below 0. So is 4, which is our low, is 4 an outlier? No, because it's not 37.5 points below the bottom of the box. How about on the top? What's Q3 plus 37.5? 92.5. Is 110 above that? Yes. So 110 is an outlier, but 4 is not. So 110 is an outlier. 4 is not an outlier. Does that make sense?
No.
Okay.
I'm lost.
So where did I lose you?
37.5.
Okay. 37.5 is the 1.5 IQR.
Mm-hmm.
All right. Now take that number and add it to Q3. Yeah, that's important. In other words, is it beyond that far above the top of your box? Okay, what is 55 plus 37.5? Well, it turns out to be 92.5. Now the question is your top number above 92.5? Yes. Ah, so 110 is an outlier because he's above that 1.5 IQR barrier. Then do it on the bottom end. Take Q1 and subtract 37.5. Well, if you do that, you're going to be below 0. So what does that tell you? This guy down here is not past that. So this guy is not an outlier, but this guy up here is. Anybody else have a question on that? So I know there's no short, I'm sorry there's no nice name for that, but that's called the 1.5 IQR rule. And on a test or something, I might give you some data and say, are there any outliers here? And I don't want you just to go, yeah, they're both far out. We want you to actually use this little formula and check it out. Now you have an official way of finding out. Okay? So we're pretty much done with that. And it's on to standard deviation. Okay, so let me just recap. Today, our chapter is a lot about central tendency and spread. How do you find the center? 3 ways. Mean, median, mode. How do you find the spread? So far, 2 ways. Range, just subtract the high minus the low. And the other one is maybe, it's coming right now, standard deviation. This is the more precise way. I mean, just knowing how far it is from the high to the low, you know, what if the high and the low are outliers? Then is the range very important? Not as. So you need something that considers all the points, not just the extremes. And that's Mr. Standard Deviation. Okay. Yeah, it's all right. This is going to look a little scary, but it won't be bad, honest. So first of all, actually there's three ways to measure spread. Range, I already told you. Maximum minus the minimum, right? In our problem we did earlier, it was 110 minus 4, which was 106. Okay, then there's a variance and a standard deviation. Actually, there's really only one formula here. Do you notice how this one looks an awful lot like that one? Look at these two formulas. Aren't they almost exactly the same? Yeah, the one on the bottom is just the square root of this one. So really, you don't have two formulas here. There's really only one. So I'll just go through what this thing says here. Okay, you guys all recognize the square root sign. And remember this guy? This is just add them all up. I haven't shown you this. I should have put it on, if you go, wherever you have the mean in your notes, the symbol that's usually used for the mean is a letter with a bar over the top of it. X bar that means the mean. So maybe if you back up in your notes a little bit, where you have the mean, why don't you just write down, I mean, X is usually the variable, so X bar is the what? The guy indicating the mean of all the X's. So what this is saying is, take each individual data element and subtract the mean from it. So take each element, subtract the mean from it, and square it. And then do that with each data element, add them all up, divide by n minus 1, and then take the square root. And all the variances is the same thing without taking the square root. Now, the formula is kind of intimidating, so I'm going to show it to you in English also, in steps. So if you'd rather, I'm just going to show it to you in 5 steps, and I'll come back here if you'd like. And we're going to just do this one step at a time. Step 1, find the mean. Okay, now I made a little chart to help us do this. The first column, I'm just calling X, those are our data elements. The second column is where I'm letting us have space to subtract the mean from each item. The third column where we can square each of those. And then we're going to follow through and do all 5 of these steps. So step 1, find the mean. Well, you guys know how to find the mean. Add them up. What do we got? 5? I'll give you a clue. I set this one up to work real easily because it's a long process. Okay, so what do we get here? 8, 18, 33, 50. And what's 50 divided by 5? 10. So what's our mean? 10. Yes? Okay. Now, take each data element and subtract the mean from it. Okay, 3 minus 10, negative 7. 5 minus 10, negative 5. 10 minus 10, 0. 15 minus 10, and 17 minus 10. Yes? Subtraction. Now, step 3, excuse me, take each of those differences, those answers I just wrote down, and square them. Negative 7 squared, 49. Negative 5 squared, 25. 0 squared, 0. 5 squared, 25. 7 squared, 49. But you notice we won't have any negatives left in this step because whenever you square a number, If it was negative, it's not going to be any more. And actually, that's one of the reasons that it's done, to get rid of the negatives. Because otherwise, what would happen if you add this column up here? It's going to come out to 0 every time. And that tells you absolutely nothing. But now that we have squared them, notice what step 4 is. Hopefully you can, I'll move this down a little bit so you can see it better. Step 4 says total the squares from step 3. So we need to find a total in this column. Okay? 14, 19, 28, 6, 8, 10, 14. If I add it right, we get a total of 148. What's step 5? Divide your total by n minus 1. Now, what is n? N means how many numbers did you start off with? We started off with 5, right? So I'm going to be dividing by 1 less than that. So 148 divided by 4. And the answer is 37. And I only have one step left. Take the square root. So the standard deviation of this item is the square root of 37, which is just a little bit over 6. Right? Square root of 36 is 6, so the square root of 37 is just a little bit greater. All right. I'll just go through this again. There's a 5-step process. Really, we're doing that formula I showed you on the previous page. Step 1, you got to find the mean. Okay, take your data and find the mean. Step 2, subtract the mean from each of your data elements. Step 3, take each of those subtraction answers and square them. Step 4, add the squares. Step 5, divide that total by 1 less than how many numbers you had in the beginning. And the last step, step 6, whatever that result is after dividing, take the square root. You now have the standard deviation. Now I just have to make a comment about standard deviation. You're probably thinking, well, so what? The standard deviation is a little bit over 6. You know, whoopee-doo and 3 skidoo. I wouldn't blame you. It's not, you don't, see, here's the problem. For a short time, I need you to just kind of bear with this. I had to show you how to do it before I can tell you what it is. And I can't give you a feel for what it is quite yet, but we're going to be there real shortly. So what's the big deal? 6.1 or whatever that is. What does that mean? Hang on. That's one of the coming attractions. I'm sorry I can't tell you right away. Okay. I will wish you a happy weekend. If you haven't read the chapter yet, you want to get in there and add to your notes by reading. Thank you. Have a good weekend.